Hello everybody, and welcome to a screencast about list comprehension in Clojure. During this screencast I'm going to try and explain what list comprehension is and how it works in Clojure, when it's applicable to use list comprehension, and finally I'm going to try and tidy up any loose ends that I create along the way. So let's start with what is list comprehension? Well, it's a feature that a number of different programming languages have, which enables easier and more succinct approach to processing multiple lists. And if you know anything about the history of Clojure, you might be thinking, well, hang on, isn't Clojure a Lisp, a dialect of Lisp, and doesn't Lisp stand for list processing? So why would a language with that heritage have the need for additional help in terms of processing lists? Well, I think the answer to that question is that Lisps are good at applying functions, even multiple functions, to a list. But when you start trying to manipulate multiple lists simultaneously, that's where it gets a bit trickier with the standard Lisp syntax. And that's exactly where list comprehension comes in. So let's hop in and let's have a look at what list comprehension looks like in Clojure. And you use something called the for macro. And if you've come from another language like C, C++, or Java, you might immediately be thinking of for loops, but that's a little bit of a misdirection. But let's first what we're going to do is we're going to define a var called number, and we're going to assign that to a vector of three numbers, 1, 2, and 3. And then what we're going to do is have a function, and all we're going to do is we're going to multiply each number by 2. And let's run that and see what we get. Okay, so we get the output 2, 4, and 6. And let me explain what's happening here. So the way I think about the for macro is in my head I say, for each number in the list 1, 2, 3, evaluate this expression. And in this case, that's just multiplying the number by 2. So it's just a way of looping over. I know I said it's not a for loop, and it's not really, but it's a way of iterating over this list and applying an expression to each value. And at this, if you know a little bit about Clojure, at this point you might be thinking, well, hang on, couldn't we do the exact same thing just with the map function? And the answer is yes, we could. Let me show you how that would look. So let's map an anonymous function, and we'll just do multiply the argument by 2, and then give it the same list 1, 2, and 3, and run that. And of course we get the same output. And in this case, I could definitely be convinced that I would prefer to use map over the for macro in this case, over list comprehension, because it's straight to Lisp or Clojure syntax. You don't need to know this DSL or domain-specific language that's created with the for macro. You don't need to understand how you read for each number, apply this. But as I said before, where list comprehension comes into its own is when you have multiple lists. So let's take a look when we have two lists that we're going to be processing with this macro and see how that could look. So again, let's specify the number 1, 2, and 3. And now we're also going to have another list, and this time we can use something like letter. Let's use a letter, and let's make that a vector of 3 letters, which in this case are actually keywords. And then let's apply a function. What's a simple function we could apply to them? Let's just string them together. So let's string the number and the letter together, and let's see the output that we get there. Okay, so now we get a list that just says 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. So what's happened here, if we go back and read this, what we said is for each combination of number and letter, apply or evaluate this expression. And that's quite powerful, because if we wanted to do this with maps, we can, but I think we're going to have to do nested maps. So let's see how we would do this. So if we have let's actually give it a function that takes a parameter so we can make it look a bit more like the other one. So we have a function that takes a number, and then we're going to need to map again. So the actual function will be nested maps, and this time we'll have the letter. And then in the innermost map, we can actually do the same evaluation, string number, letter. And then we're going to need to be applying that to the letters A, B, and C, and then finally on the outermost pair of parentheses we're going to have the numbers 1, 2 and 3. Now the color coding in my light table thing makes it a bit easier to see where that these numbers are applied on this function and that the orange vector is applied on this function. But even with that, I would argue that this is actually much harder to reason about and to think about than the list comprehension version. Let's run that and see it's the same. Oh, it's not quite the same result actually, because we need to concatenate it because it's done it as 3 separate lists. So if we just we could do an apply cat, or we can just do map cat. That should give us the same result. Yeah. So I think you'll agree with me that the for macro, the list comprehension in Clojure, has enabled us to do clearer, more succinct code to get the same result. And this only increases as we get even more lists as input. So let's take one where we have 3 input lists. But this time let's change it up a bit. Let's think about a more real-world type of example. 3. Okay, so let's think about, I don't know if you've ever seen a suitcase or a padlock that has 3 combination dials. You know, we can dial the numbers in. So let's try and model one of those using list comprehension. So let's say tumbler 1, and I think the one I have that I use for the gym actually has a range of 0 to 9. And if you remember about the range function in Clojure, let's just quickly show you. If I do range 1 to 10, wrong number of arguments. Let's just comment out the 4. I think it's actually inclusive for the start of the range and exclusive for the end. So it includes the 1 and it excludes the 10. And if we don't give it any start, it will default by being 0 index, starting at 0. So that's how range works. So range 10 here is going to give us 0 to 9, which is exactly all of the combinations of each individual tumbler. So let's set up 2 more tumblers. Tumbler 1, tumbler 2 also has the same range, range 10. Tumbler 3, same range, range 10. Okay, and what are we going to do? What's the expression we want to evaluate? Well, let's just create a vector that just shows the value of each tumbler. So if we execute this, we're going to get every single combination for a 3-dial combination lock from 0, 0, 0 all the way through to 9, 9, 9. And if you look, you see that it's the last expression, or the last var that you define, the last list that gets incremented first. So we go 1, 2, 3, 4, 5, 6, and then we start doing the second one. 1, and then it's 2, and then finally it's tumbler 1. So then we get all the way up to 999. And we could count this if we wanted to know how many different combinations are there for that kind of lock. So let's just put a count in front. Let's fix the formatting a little bit and run it again. So there are 1,000 combinations for that kind of lock. And you might think, well, if you know basic statistics, it's a pretty simple combinatorial expression. You could just do 10 times 10 times 10 and have the same output. So why have I done this as list comprehension? But list comprehension actually comes with a couple of neat additions, ways of restricting or filtering which combination. So this is saying for each combination of tumbler 1, 2, and 3, apply this expression. But we can use the when filter to say only do it when. So let's think. So let's say we wanted to only see the ones where one of the tumblers is showing 4. So let's say equals 4 tumbler 1, or equals tumbler 2 4, or equals tumbler 3 4. we run that one, and let's not run the count, let's just run the for. So if you look, every single, so 0, 0, 1 is filtered out because it doesn't match, because this is a predicate expression that returns true or false, and it will run this when expression for each combination. So in if you remember, without the when, the first one was 0, 0, 0, but because it isn't true that neither tumbler 1, number 2, or number 3 are 4, that one gets filtered out, so it ignores that one. And the first time that we get to one where one of these is 4 is 0, 0, 4. So if you look, every single one of these has at least one of the tumblers is 4. So that's kind of cool. And then if we count that, how many of those do we have? So there are 271 combinations where at least one is 4. And what happens if we would say, okay, what happens when tumbler 1 is equal to tumbler 2 is equal to tumbler 3, and tumbler 3 is equal to tumbler 1. And let's run this and see what we get. So what we're saying here is at least one pair of the tumblers should have the same value. So if you look here, in every single one, at least, of course you might have ones where all 3 are the same value, that's fine because it's an OR, but you always have at least 2. And if we count that, how many do we have? 280. So what it's enabled us to do, because 4 is generating all of the combinations in a really nice way, it's given us data, and the when clause isn't allowing us to filter out data based on what we're interested in. And it's still succinct. It's not much code, and quite readable code, in my opinion, for doing something quite complicated. And to do this with maps or with standard Clojure, I'm sure you can do it, but I think it would probably be much more code and probably harder to read and understand. Okay, so that's the basic introduction. Now hopefully you've got some idea of what list comprehension is. But when should you be using it? Well, basically whenever you have multiple lists that you want to process down to one list, and especially if you have some filtering that you need to do. And to help you think about it, I was recently working on some production Clojure code in a system where I needed to generate some unique ticket numbers. And part of the requirements was that the ticket numbers had to end in a 2-letter combination. So, and the range of valid letter combinations was AA all the way through to ZZ. So it was AA, AB, AC, AD, etc. So each additional ticket would get the next serial number, if you like, or it's a way of uniquely identifying the ticket. And when I read the requirement, the first thing that jumped into my mind was, okay, well maybe list comprehension would be a good match for this. So let me show you just quickly, if I can remember exactly how it looked. It was something like this. So I had 2 letters, letter 1, and what I did there was they wanted the capital letters, and then we had letter 2, which was also the capital letters, and I'll define capital letters in a second. And then all I did was, once I'd done that, I just did a string of letter 1 and letter 2, much like we did earlier. Oh, hang on a second, I'm just going to pause the recording. My daughter is waking up. Okay, I'm back. So yeah, first we're going to need to define a list of all the capital letters. So let's define capital letters, and it's going to be the range of the capital letter A to capital letter Z. However, range doesn't work with characters, it works with integers. So what we're going to need to do is convert that to an integer and convert this one to an integer. And as we saw earlier, it's start inclusive and end exclusive, which means we're going to need to increment the Z to make sure that we actually get the Z in. So we go 1 past the Z to include it in the range. So let's just evaluate that and see what we get. Yeah, 65 to 90, that looks right. And now we have a range of the integers from A to Z, but let's now convert those back to characters. So let's just map the char function across those. And now hopefully, if we evaluate capital letters, we should have A, B, C, D, yeah, A to Z, perfect. So those are the capital letters. So now if we evaluate this list comprehension, we have all of the combinations of AA all the way down to ZZ. Perfect. But my requirements didn't stop there. For these uniquely identified tickets, they didn't want the letters I or O to be included. I think the reason was because they're too similar to the number 1 and 0, so when people were calling in and reading out their ticket numbers, they didn't want them to get confused. But that's pretty easy, because what we can do is we can define some blacklisted letters, and we'll just create a set, and we'll say that we don't want to allow I and we don't want to allow O. So we have a set of blacklisted letters, and now we can use the when that I was talking about before, the filter, and we can just filter out on those. So we'll say when not blacklisted, letter 1, and whoops, no, there, and not blacklisted, letter 2. Now what I'm doing here is I'm making use of the fact that a set in Clojure can actually be used as a function. You'll see here I'm using it as a function. So saying blacklisted letter 1 is basically the equivalent of saying contains blacklisted letter 1. It just means we slip using contains. So let's run this. Unable to resolve symbol blacklisted in this context. Oh, because I haven't evaluated it yet. Let's run again. So if everything has worked as it should have, we should see that we skip over I. So let's have a look. So do we have a H and a J? So we skip over I and we skip over I entirely. So this gives us the entire set of letter combinations that we want. And if I just evaluate out here to get rid of the live evaluation, you'll see that it's not much code, and I actually think it's quite readable. So let's think about what we're saying here. So we're saying for each combination of capital letters, letter 1 and letter 2, when those letters are not blacklisted, so and not, so when neither of them are blacklisted, print out the combination as a string. And yeah, it was just in this case, list comprehension perfectly matched what I was trying to do. So it's just an example, a way of thinking of when can I use it. And for me, list comprehension is just, it's another tool in the Clojure toolbox. It's just something else that you can pull out when the situation calls for it. Okay, so that's a little bit about when. What about and? Is there anything that I've missed? And actually there is, because if I'm doing a screencast about list comprehension, I should talk about all of the features of the for macro in Clojure. And there are a couple of others that I haven't talked about yet, so let's briefly show those. So let's go back to our basic example that we had at the top, where we had a number that we've defined. And what can we do with it? Okay, yeah, so there are two other clauses, if you like, as apart from when. You can also do a let. So let me show you how let looks like. So if we say, let's define it as tripled, and then have an expression which is the number times by 3. And what this allows you to do is to use one of the lists that you've already defined and actually do something with it, have an expression that manipulates it. Whereas if you have two completely independent lists, as we do here, where we have numbers and letters or ranges, these are not talking about each other, they're separate. So in those cases, you don't need to use a let, but if you want to manipulate a list that you've already defined, you use let. So let's see how this would look. So let's just output tripled and run that. So yeah, it gives us the result we expected. 1 times 3, 2 times 3, 3 times 3. And there's another, as well as doing when, there is another way of filtering out, and that's using while. So let's try and see what while looks like. So while those are odd, tripled, And look at this, we only get 3. If I swap that to a when and run it, we get both 3 and 9. So it's only allowing the odd triples through the filter. But if I use while, we don't get the 9. And the reason is because it evaluates 3. Okay, it passed this predicate, fine. 6, 2 times 3 is not odd, so it fails, and it fails fast. So the while says keep processing the list until you hit something that doesn't match this predicate. I haven't come across a use case in real life of when I would want to use this, but I guess it's going to be performance based. If you have everything you want to process at the start of the list, and then as soon as you hit something and the whole rest of the list you don't want to process, then you would be using while. Okay, so those are the two other parts of list comprehension in Clojure. Is there anything else to talk about? I think I've covered what I wanted to cover, but one thing I did want to do was to quickly, now with this knowledge that we've gained about list comprehension, is try and solve a problem using list comprehension. So what I'm going to do is I'm going to go to a website called projecteuler.net, and this is a great website if you're learning any programming language. But I guess if you're watching this, you're interested in learning Clojure right now. So I can highly recommend working through some of these just to practice pulling out the different parts of your Clojure toolset to solve them. And actually the first problem here, multiples of 3 and 5, is actually a very good one for using list comprehension, but it's a little bit easy. So what I wanted to do was leave that for you guys as an exercise for the reader, for you to practice on. But the one we're going to solve is this one, number 4, largest palindrome product. So let's read this quickly. A palindromic number reads the same both ways. The largest palindrome made from the product of 2-digit numbers is 9009. 91 multiplied by 99. And here's the problem. Find the largest palindrome made from the product of 2 3-digit numbers. So when I read this, I'm automatically thinking of list comprehension, because I'm thinking, okay, so we've got all the combinations of 3-digit numbers that we want to multiply together and get the products of. So I've got 2 lists, and I want to filter out only the ones that are palindromes. So to me, this is screaming list comprehension. So let's try it and see how it works with list comprehension. Okay, so start with the for macro as always, and let's define a 3-digit number. 3-digit number 1, because we're going to need 2 of these. And again, we're going to use the range function, and this time we're going to, so the range for 3-digit numbers is between 100 because it's inclusive and 1000 because it's exclusive. So that will give us 100 to 999. Great, and let's do it for the second 3-digit number. Again, we'll use range 100 to 1000. Okay, and here what we're going to have to do is calculate the product for each combination of these. One way of doing that is using the let clause that we were talking about before. So let's call that the product, and let's just make that multiplied 3-digit number 1 by 3-digit number 2. There's the product. And now we want to filter out and only allow the ones that are palindromes through. So let's now use the when clause and say when palindrome product. So when the product is a palindrome, let it through, and then we're just going to show the product. So we need to define a function, a helper function that figures out if a number is a palindrome. So let's go ahead and do that straight away. Palindrome, we're passing in a number. What's the easiest way to do this? I guess the one way to do it would be to convert the number to a string and then just compare it to the reverse of the string. I think that might be the easiest. Let's try that. So let's convert the number to a string and then compare it to, if we use Clojure, if I can type Clojure.string reverse, and then we're going to have to string the number. Would that work? Let me just try that quickly. I'm not sure that. palindrome 10, false, palindrome 11, true, palindrome 100, false, 101, true. That seems to be working perfectly. Okay, so let's run this and see what it looks like. Okay, so here we go. Here is a list of all of the palindromes for all of the 3-digit combination of 2, 3. There are a lot of them. Okay, so we need to, if we go back to the requirements, find the largest palindrome made from the product of 2 3-digit numbers. Okay, so we need to find the biggest one of those. So let's use the max function. But because this is already a list, we're not going to be able to use max directly. We're going to have to do apply max. Let me just explain why that is. Just a second. So let's get rid of that one. So the max function, if we say max between 1, 2, and 4, it's going to say 4. But you see that those are 3 separate parameters. But if we say what's the max of 1, 2, and 4, it's just going to return the entire list, which isn't what we want. Whereas if we say apply max, it will return 4. So that's why we're using apply max. Okay, so let's run that and see what the answer is. 906,609. So I think that's the right answer. And as you can see, it's not much code. It was very easy to think about and to write. And hopefully now that you understand that this domain-specific language around processing lists, you find this quite readable. So let's go through it. So for each combination of 3-digit number, and that's the range between 100 and 1000, calculate the product and define it as this temporary var. So it's 3-digit number 1 times 3-digit number 2. And when they're a palindrome, evaluate this, and we're just returning the product. So we got a list of the products basically, and then we've just applied the max to get the largest one. And in not much code at all, we've solved this problem. So hopefully that's shown you how you think about when it's applicable, when list comprehension is useful, how it works, and yeah, hopefully you can go out there and add this to your Clojure toolbox. Thank you very much for watching this screencast, and I hope to see you again in the future. Cheers.